What we'll have a look at in this video is asset performance monitoring using Ampla. What we've got here is a very simple scenario of an asset running over a period of time with some rate delays as well as a stoppage in the middle there. So in the example we have here, we're seeing that the fictitious asset has a limitation of 100 units per hour. And then we also, on the x-axis, we're looking at time moving forward. So you can see there somewhere between sort of 10 a.m. moving through to 8 p.m. or so. So in the scenario we have here, you can see that the green represents when we're running at rate. And as we step through there, there's periods of time where we drop below that running rate into what we would call a reduced rate type of mode, or with a delay there. Then we're returning back to rate. We also have in the middle there a period of time where the asset is stopped and not producing, and then we also ramp up to a healthy running rate again, and then there's quite a drop towards the tail end there where we're running well below the target rate. Okay, so with Ampla, what we typically would do is we would install a downtime reporting point to track these losses on this asset. So you can see here that we have two distinct types of loss, and that would be stoppages, so the example in the middle here, as opposed to reduced rate losses, that we have a number of those through here. So you can see here that we have obviously a 100% loss when the asset comes to a stop here for a period of time. But here we have, say, a 20% loss for this period here. We also have a significant loss while the asset is ramping up to rate during this period. So it's not actually stopped, it's in a running state, but it has a variable rate of loss there that's captured. And then toward the end here of the scenario, we also have another significant rate loss. And so what Ampla is doing, it's capturing those events, and it's also then assigning a percentile of loss. So a stoppage, you're seeing 100% of the asset throughput gone, and when you have a rate loss event, you're seeing, in this instance, we're seeing 20% of the throughput is being lost due to that event. In this instance, where it's ramping up, we're losing 50% of the throughput, and in the final example, we've lost 40%. So the idea here is that when we're analysing the performance of the asset and its ability to produce desired output, we want to understand what those losses were that occurred and where that time went. So when those events are being created in Ampla automatically based on tags and logic, we then have to populate those, or we can populate those with auto-completion logic or manually, and we're populating them typically with a cause location. So what was the piece of equipment that failed, a cause code being a nice generic cause code being level low or broken, C's jammed or meeting or weather or something like that. And then the classification is the third piece of information that typically links to the business group that was responsible for that type of loss. So in this instance here, we can see we've got a 20% loss where we're saying that the feed stockpile was the cause location. That was due to the level being low, so they've backed off the feed, trying to maintain a consistent flow, and that was an unscheduled operational loss. Whereas the middle example, we're seeing that we have a full stoppage here where the asset is stopped altogether. There was a problem with the gearbox, and we're saying that that was seized and jammed was the cause, and that's an unscheduled mechanical classification. So if we now have a look inside the Ampla client at some example event records here, what we can see is that when the records are being captured by the system and the logic is generating the understanding of those stopped and slow running states, we're capturing a start time and an end time. We're also capturing the duration of the event, so you can see here that we have quite clearly the duration, and this here is the effective loss. So you can see here that this particular row that's highlighted is a stopped event or a full downtime event. It's suffered 100% of the loss of this particular asset. Therefore, the duration that was recorded of 3 minutes and 5 seconds is the actual effective duration that the plan has stopped. Whereas if we look at a different record here, the one above it, we have a stoppage that lasted for 4.5 minutes, and because it was losing somewhere around half half the rate, or 50% loss, we can see that 4-minute 30 duration is the equivalent of that full plant being stopped for 2 minutes and 16 seconds. So this effective duration column allows us to sum together stoppage delays and slow running delays in order to create a sum total of loss for that particular period of time, which is very powerful. You can also see in the delays we capture the cause location as mentioned before, the classification being operational or mechanical or something like that. And then we have cause codes, again quite clean and clear. We want the data to group together nicely, so when we analyze that it makes a lot of sense. And you've also got information like comments, so you want to get some of those operator comments as well, which can be very powerful. Okay, so now if we have a look at a broader range of values in Ampla, we have some example data here with almost 4,000 delay records. We can see that if we turn on the grouping pane in Ampla, it allows us to group the records by their record type, and you can see here that there's a significant amount of time captured in stoppages, full delays, 51 odd days, but importantly we also have a very substantial amount of slow running. So we have 16.5 days of full plant stoppage equivalent that was captured as slow running or rate loss type delays. So that's again very powerful. If we have a look at the charting pane down here, we can see that those records are inside of this pie chart, and you can see here that I have this grouped by that time classification, and if we hover over there we can see that a large portion of that is unscheduled operational. We can drill into that and have a look at what the composition of that unscheduled operational delay time was. We can have a look at options such as the crew that we were operating at the time the delays occurred, whether it was day or night shift. We can see in this instance we'll have a look at the cause codes that made up that unscheduled operational time, and you can see here that it makes it very clear what the most common causes were of that delay time. So there you go, like just over 5 days of blocked and bogged delays, material build-up delays. Now these would be areas that the operations team would target to try and reduce or eliminate some of this delay time. Another useful way of visualizing the delays in Ampla is by taking that data into a BI tool like Tableau in this instance. What you can see here is delays that have been grouped on cause code, and they've been colored by the classification. So again, we have the unscheduled operational or unscheduled mechanical, or even the scheduled time that has been completed in each and every delay. And again, it makes it very clear in here, if you look at the bulk of the time that has been lost by this particular asset, there's a lot of this comes down to unscheduled operational. So again, if you look at some of these cause codes, you can see here that there's a high likelihood that the operator would be able to train crews a little bit better to try and reduce some of the material build-up losses and blocked and bogged type delays. So hopefully after watching this video, it gives you an idea of the power of capturing the stoppage and reduced rate delays using Ampla and populating those delays with valid cause classification type information. Thanks for watching.